Good evening, students. Today we are going to discuss an important topic in grade 11 chemistry, that is Heisenberg's uncertainty principle. In the previous lecture, we were discussing about dual nature of electron. What is meant by dual nature? Electron can show the particle properties or particle nature, and it can also exhibit the wave nature. So we were discussing about de Broglie's wavelength earlier. So now the second important principle was given by Heisenberg. So Werner Heisenberg in 1927, he has proposed a principle. So what he says, according to him, it is impossible to determine simultaneously what we cannot determine simultaneously: position and velocity of an electron or any subatomic particle, or you can also say we cannot identify or determine simultaneously the position and momentum of an electron. So based on this, he has given an important formula that says delta x into delta p is greater than or equal to h by 4 pi. Now what is delta x here? Delta x is nothing but uncertainty in position of any subatomic particle. We can consider this. Now second one, here we have delta p, uncertainty in the momentum, and we know what is h. H is nothing but Planck's constant. During numericals we can write the value of this, and so this is first one. Now when you are equating with momentum, we know that momentum is equal to mass into velocity. We can write like this: delta x into m delta v. Why we have written m here? Because m is constant, so delta v is nothing but uncertainty in velocity, is greater than or equal to h by 4 pi. So sometimes they will ask only delta v. So in that case we can write the formula: delta x into delta v is greater than or equal to h by sending m to here, we can write 4 pi m. So we got three formulae. Depending upon the question, we can solve this. So hope you have understood. Now once again, if you revise, it says, so what is dual nature of an electron? An electron will show both particle nature as well as wave nature. Earlier wave nature, that is by de Broglie, we know that lambda is equal to h by p or h by mv or h by root of 2 into kinetic energy into mass. This we have discussed. Now in 1927, German physicist Heisenberg has given that it is impossible to determine simultaneously. So simultaneously together we cannot identify position and velocity or position and momentum of an electron. Accordingly, he gave three formulae. First one is delta x into delta p greater than or equal to h by 4 pi. Second one is delta x into m delta v greater than or equal to h by 4 pi. And last one, if you see uncertainty in velocity, nothing but delta v is uncertainty in velocity, h by 4 pi m. Hope we have understood the formula. Now let us see some numericals on this. Now let us see the numericals. So first let us solve ISC numericals, then we will see competitive exam questions. In this question number 1, we have a ball of mass 175 gram moves with uniform velocity. It is located with an error equal to 5500 angstrom unit. Calculate the uncertainty in velocity. First and foremost thing, let us write the symbols here. Mass m is equal to 175 grams can be converted into into 10 to the power of minus 3 kg. Next, so we have delta x, that is uncertainty in position 5500 into 10 to the power of minus 10 meter. Because angstrom is given, we have converted into meter. Now the question is find out delta V. So H can be taken as 6.626 into 10 to the power of minus 34 joule into second. And we know the formula. Delta x into m delta V is greater than or equal to H by 4 pi. So remaining all we can send to the other side. So let us write delta V is equal to H by 4 pi m into delta x. Hope you are able to understand this. Next, substitute the values here. H value 6.626 into 10 to the power of minus 34 divided by 4 into pi value 3.14 into, so mass 175 into 10 to the power of minus 3. So this is mass. And finally, delta x is 5500 into 10 to the power of minus 10. So you can also do one thing, this we can take it as into 10 square. First, try to solve 10 to the power. What is that? 6.626 into 10 to the power of minus 34 by 4 into 3.14 into 175 into 55. This value we can calculate separately. Now here we have minus 3, then minus 8, nothing but minus 11. If it comes to the numerator, we get into 10 to the power of plus 11. So 34 and 11 we get minus 23. So hence this whole thing into 10 to the power of minus 23, and the units we can say meter per second. Now what is the value you got? You got finally 5.48 into 10 to the power of minus 28 meter per second. So for your convenience, I have calculated the value, and using the formula delta x m into delta v is h by 4 pi, you can get the answer. So hope you have understood. Delta v is 5.48 into 10 to the power of minus 28 meter per second. So question number 1 is done. Now let us move to question number 2. So what is given in the question number 2? They have given uncertainty in momentum, we have to calculate, that is delta P should be calculated. They mention uncertainty in position, delta x is 1 angstrom, you can write 10 to the power of minus 10 meter. So you know the formula, nothing but delta x into delta P is greater than or equal to h by 4 pi. So h value alone you can write 6.626 into 10 to the power of minus 34 joule into second. Substitute this and find out. So delta P we have to calculate h by 4 pi into delta x. 6.626 into 10 to the power of minus 34 divided by 4 into pi value 3.14 into, so delta x 10 to the power of minus 10. Now this comes to numerator, becomes plus 10. 6.626 into 10 to the power of minus 24 by 4 into 3.14. So we know that delta P unit kg, mass into velocity meter per second. So I have calculated this. The answer you get it as 5.27 into 10 to the power of minus 25 kg into meter per second. Hope you have understood this. Very simple. To calculate delta P, we can use delta x into delta P is equal to h by 4 pi. So as you can recollect, the uncertainty in position, the uncertainty in momentum cannot be calculated simultaneously according to Heisenberg's uncertainty principle. Question number 2 you have understood. Now coming to the question number 3, this is given in the review exercise questions. The same question we have solved earlier, that is question number 1. Now let us see what is given. Calculate uncertainty in velocity, that means delta V. We need to calculate uncertainty in position. Delta x is given as 10 to the power of minus 11 meter and h is 6.6 into 10 to the power of minus 34 joule into second. Don't forget to write the unit. Unit also carries marks. M is 9.1 into 10 to the power of minus 31 kg. This is given. Now, what is the formula? Delta x into m delta v is greater than or equal to h by 4 pi. To find out delta v, we can write like this. Send this to other side. We have 4 pi into delta x into m. Now, substitute the values. H is given as 6.6 into 10 to the power of minus 34 joule into second divided by 4 into pi value 3.14. Next, delta x uncertainty in position 10 to the power of minus 11. And what is the mass here? You know, electron mass is 9.1 into 10 to the power of minus 31 kgs. Again we know, first let us calculate 10 to the powers here. What we have, this is nothing but minus 44. So 10 to the power of 1131, that is nothing but 42. If it comes up, you have 10 to the power of plus 42. So minus 10 to the power of minus 34, you get 10 to the power of 8. That is nothing but 6.6 by 4 into 3.14 into 9.1 into 10 to the power of 8. So delta V unit, you know, meter per second. So what is the final answer? I have calculated that. So you have 5.77 into 10 to the power of 6 meter per second. To save time, I have calculated it earlier, you know. So simply divide this value, you will get the answer. So 5.77 into 10 to the power of 6 meter per second. So third question also we have solved. Hope you have understood this. Let us now take objective questions. Now let us see the objective questions. First you try to understand the question and take some time to solve by pausing the video, and then afterwards you can see the solution. Hope you have understood this. You know the formula and you have the question. So try to solve this. If you are not able to solve that, then you can see the solution. Now the first question is uncertainty in the position of electron and proton they are considering, and it is equal. So we can write like this: uncertainty in position of electron is equal to uncertainty in position of proton. Now they say what is the ratio of uncertainty in the velocity of electron and proton. We can write like this: delta VE by delta VP. We have to calculate. Very simple. Hope you have understood the concept here. Now they are asking what is the ratio of uncertainty in velocity of electron and proton. You know the formula. So what is the formula? Delta x into m delta v is greater than or equal to h by 4 pi. Now we want only delta v. If you want delta v, it is nothing but h by 4 pi into delta x into m. See, in both the cases we know h by 4 pi gets cancelled out. So we can write like this. What is the first one? Delta VE, we can take it as so 1 by delta x into the mass of electron. Now they have mentioned both are equal, hence we can also cancel this. So is equal to this by 1 by delta x into mass of the proton. Now on calculation we get 1 by delta x into me into delta x into mass of proton by 1. Both are equal, hence you can cancel. So what we get finally? the ratio of uncertainty in the velocity of electron by uncertainty of velocity of proton is nothing but mass of proton by the mass of electron. See, they didn't ask you in terms of values, but you can just identify that the mass of the proton is 1836 times. So if you are taking electron mass is 1, then this will be definitely 1836. So what is the answer? Option D is your answer. Hope you have understood this. Very simple. By using Heisenberg's uncertainty principle, you can get the ratio of uncertainty in velocity. Try to understand the question number 2 and solve it. Take some time. You know the formula. Try to solve that. By pausing the video, you solve it and then check the solution. Now solution for question number 2. A ball of mass. First write the terms here. M is nothing but 200 gram. We convert into kg, 10 power minus 3 kg. Moving with velocity of 10 meter per second. So V is equal to 10 meter per second. Understand that here they are not asking you delta V. They have given you only velocity. And they say error in the measurement of velocity is 0.1%. That means we can write delta V is equal to 0.1% of 10 meter per second. Hope you are able to understand. So this we can write like this. So now what you get? Nothing but 10 to the power of minus 2 meter per second. Delta V we got. Next they are asking find the uncertainty in position. We can write the formula. That is Heisenberg uncertainty principle. Delta x into m delta V is greater than or equal to h by 4 pi. Now we know all the terms. Delta x is equal to h by 4 pi into m delta V. So what is h here? Planck's constant. 6.626 into 10 to the power of minus 34 joule into second by 4 into pi value 3.14. So what is the mass you got? 200 into 10 power minus 3. So you can also convert 10 square, right? So here it is 10 square. Nothing but 2 into 10 to the power of minus 1. 2 into 10 to the power of minus 1. Delta V we calculated as 10 to the power of minus 2. First try to calculate 10 to the power here, then you will calculate the numerical value. So for saving time I have calculated earlier, and what I got is 2.64 into 10 to the power of minus 32 meters. Hope you have understood this, how to solve using, so delta x into m delta V is equal to h by 4 pi. Now let us move to question number 3 and 4. Next let us see question number 3 and 4. For a few minutes you just pause the video and try to solve the question. It was asked in AIEEE 2009 and the second question, that is AIEEE 2006. So how to solve this? Again using Heisenberg's uncertainty principle. Question number 3, they mentioned in an atom electron is moving with the speed. So nothing but we can take V is 600 meter per second. Accuracy is 0.005. So we can calculate delta V is 0.005% of 600. Now we get 0.30, nothing but 0.03 meter per second. So uncertainty in velocity you got. They're asking uncertainty with the position of electron, delta x you have to calculate. So h is given, m is given, we can calculate delta x into m delta V is greater than or equal to h by 4 pi. Using the principle, what you need to calculate? Delta x. Send this term to the other side of the symbol, you get h by 4 pi m into delta V. Substituting the values we get Planck's constant h is 6.6 into 10 to the power of minus 34 joule into second divided by 4 into pi value 3.14 and the mass. So here an electron, hence 9.1 into 10 to the power of minus 31 kg. And delta V, so delta V we have calculated 0.03. So delta X in terms of meters. So we get 1.923 into 10 to the power of minus 3. So this value is nothing but option C. So for convenience I have already solved this. So hence we get delta X uncertainty in position is nothing but 1.92 into 10 to the power of minus 3 meter. Hope you have understood this. Now you try to solve question number 4 in less than 1 minute and find out the answer, then I will give the solution. So students, hope you have got the answer. If you get the answer, fine. Otherwise you try to check with the solution. Question number 4. Uncertainty in the position of an electron moving with the velocity. You have to find out nothing but delta X, how much. Mass is given 9.1 into 10 to the power of minus 31 kg. And they have given velocity V is 300 meter per second. And they mentioned that it is accurate up to 0.001% of this. Therefore, so uncertainty in velocity is 0.001% of 300. So nothing but 0.003 meter per second. You can also write it as 3 into 10 to the power of minus 3 meter per second. Anything you can write. Next step. So to calculate delta X, you know the formula. Delta X is equal, directly I'll write h by 4 pi m into delta V. So this formula directly we can write and substitute 6.6 into 10 to the power of minus 34 joule into second, Planck's constant, divided by 4 into pi value 3.14 and the mass. So here mass of an electron 9.1 into 10 to the power of minus 31 kg, and you got it as 3 into 10 to the power of 3. So uncertainty in velocity is 3 into 10 to the power of minus 3. So I have calculated this and we get a value of 1.924 in 10 per minus 2 meter. So looking at the options, you can see that it's nothing but 1.92 in 10 per minus 2 meter. Hope you have understood this question number 3 and question number 4. Now let us move to 5 and 6. Now we are into the last part of the lecture where we will solve 5, 6 and 7 questions. First you try to read the questions, take some time and solve, then if you are able to do that, it is fine. Otherwise you can see the solution. I'll give the hint now. Mass of an electron, they have mentioned m is 9.8 into 10 to the power of minus 28 gram. CGS units is followed in this question. Uncertainty in velocity delta V is given as 2 into 10 to the power of minus 3 centimeter per second. So no need to change because they have given the answer also in CGS unit. Uncertainty in the position of an electron here is delta X, we need to find out in terms of centimeter, and H value also in CGS unit. So formula, you know, delta X into m delta V is greater than or equal to h by 4 pi. So we want to know only this. Send the terms to other side, you get delta X is equal to h by 4 pi m into delta V. Now substitute the values. Planck's constant 6.62 into 10 to the power of minus 27 erg into second, divided by 4 into pi value 3.14 and mass 9.8 into 10 to the power of minus 28 grams. Now what is delta V? 2 into 10 to the power of minus 3 centimeter per second. First and foremost thing is try to solve this 10 to the power of minus and plus. Then the numerical, finally the value will be delta x. You will get it as 2.7 into 10 to the power of minus 2 centimeter. But approximate value you can see that is 2.9 into 10 to the power of minus 2. Hence the answer is B. Hope you are able to understand this. Try to solve the next question. What is that? A microscope with some photons locates the electron within 0.1 angstrom distance, nothing but delta x. They are asking to find delta V. Let us keep the formula as such. Now question number 6. So they mentioned that delta x is given as 0.1 angstrom, nothing but 10 to the power of minus 10 meter. Find out delta V. So mass of electron m is 9.1 into 10 to the power of minus 31 kg. H is 6.62 into 10 to the power of minus 34 joule into second. Now substitute the values and find out delta V. We need only delta V. So we want delta V. This term sent to the other side of the equal symbol. What we get? Delta V is H by four pi into m into delta x. See, mass is nothing but 9.1 into 10 to the power of minus 38 kgs. Next, you get on substituting 6.62 into 10 to the power of minus 34 by, next one is 4 into pi value 3.14 into 9.1 into 10 to the power of minus 31 kg into delta x. What is delta x here? Is 10 to the power of minus 10 meter. Now we need to get in meter per second. So here finally you will get answer as 5.8 into 10 to the power of 6 meter per second. For convenience I have solved this earlier. So here nearest value is 5.79 into 10 to the power of 6 meter per second. Hope you have understood this. Now the last question. My target is to give you more number of questions. Hence we have taken almost 9 questions we have taken. Next. The last question, try to solve this, otherwise you can see the solution later. Now they mentioned that in solution for question number 7 we will take less than 1 minute time. Uncertainty in the position delta x is calculated as 10 to the power of minus 5 meter. So the mass is 25 gram, hence we take 25 into 10 to the power of minus 3 kg. You want to calculate delta V. Now substitute that delta x into m delta V is greater than or equal to h by 4 pi. We want only delta V. Send the terms to other side. Delta V is h by 4 pi m into delta x. So this is your formula. Now substitute Planck's constant 6.626 into 10 to the power of minus 34 divided by 4 into pi value 3.14. Now what is the mass given? So 25 gram. We will take it as 25 into 10 power minus 3 kg. Next, delta x, uncertainty in the position is nothing but 10 to the power of minus 5 meter. First solve 10 to the power of minus and plus. After that solve the numerical. Now delta V, finally we get it as 2.1 into 10 to the power of minus 28 meter per second. Answer is A. Hope you have understood. Using this we can identify the dual nature of an electron, that is both particle as well as wave nature. So this was given by Werner Heisenberg, so in 1927. Hope you have understood this. Thank you so much.